Hello. Uh, I'm actually quite surprised at the camera quality. I'm using a USB camera. Webcam, so-called webcam. Um, because my capture card is actually bricking my PC. Yes. The what happens is the XHCI controller dies. And that means all USB devices stop working. So, microphone, capture card, mouse, keyboard. So, my computer just sits there and doesn't accept any input. It just keeps playing whatever it's doing. It just keeps like OBS is just keeps streaming totally fine. Everything is running. It's happened on stream before, where a I was like playing the Strafe Client game, and it just disconnected me. The computer disconnected from the world, and I just like flew in a straight line and hit the wall. And I'm done with that. I don't think I want that to happen to my computer anymore. So the capture card is now unplugged, and I'm using the piece of crap, the so-called piece of crap. It actually looks not horrible. And like in my experience, the frame rate was quite bad, but this is okay and may not actually be an issue. I might just use it and eventually get a new capture card. Uh, hmm. So there's my vent, my rant. Where is it? Well, okay, well, I thought that might happen. It was expensive. I bought this camera system. It wasn't terribly expensive for what it is. Just $600 or so for the capture card and the camera and the stand, and like I just plug everything in and it all works. I bought it from a friend. It's a fantastic price for how long it worked well enough. It's very irritating that it just worked for years and now it just doesn't work. Huh. Right. I was looking at console. Hmm. What did I change here? Am I goober? Oh yeah, Tasta. Wait. Lol. Hmm. Hmm. You can see that I haven't started on the April Fool's update yet. I've got some stuff in mind, but I just find it impossible to work on the Beehive game seriously. Uh, I mean, I usually don't do this. Yeah, I think I'm just gonna not. Uh, let's see. Hmm. I don't remember how the game works. All right, how does this work? Ugh. I just cleaned my coffee machine so it doesn't taste like. It didn't. The flavor doesn't really change perceptibly for me. It's more like I feel sick after drinking coffee, and that's when I know. I need to clean my coffee machine. How does it get the numbers out of the thingy? There's not just like a. Jeez, this is just a massive script. Okay, so jump report. How does this happen? Ah. View output signal. I see. Ugh. Run manager. Is that the only thing? What does? Oh, context. Who? Context. Playback context. Output signal. If I. It should be like not quite right. You know. View output signal. I know things about the game. Oh, hey, someone was asking for this. Mm. Oh, 2 years ago. Mm. Oh, you know what I was thinking? The game would be useful for surf. So the energy gauge is actually just terrible, but the value is useful because you can see if you lost some of your mojo when you hit the ramp, when you board a ramp. It immediately tells you a useful. It's kind of like speed, but like it's the total energy you have as you translate between like falling energy and you turn it into speed energy, which is like potential versus kinetic energy in physics terms. And the number is quite would probably be more useful than the giant thing. Hmm. 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 Yeah, it is freaking huge, isn't it? I'm actually curious if um oh no, I was supposed to go to the other game. How big is it? Okay, it's exactly as big as my camera. That is just huge. Probably it could do with being half the size. So you can see that when you jump, it's staying constant. If I strafe, it goes up. So as I move, you can see I'm just gaining energy. But then I botched every time I like botch a board of a ramp, you can see it dips slightly. See that? So it's a very useful gauge. It tells you exactly how much energy you're losing every time you board. So it goes up and up and up and up, down, up and up and up and up and up, down, up and up and up, down. So strafing very clearly gives you energy, and then misboarding very clearly takes energy away. So probably it'd be more useful to display it as a number and have it be half the size. How let's see. Probably probably I should do like mode 1, mode 2, mode 3 or something. Uh um Why don't I just do this as a April Fool's present for surfers in general? Haha, fooled ya. Gotcha. Energy gouache. Drag bar. Energy needle. Uh. Um. Hmm. Uh. Ah. 422. Mine got 211. That is half. Oh my goodness gravy. Okay. And then oh, 22. Why is it 422? Size 240. Uh 60? Okay, bud. Pause scale. So that's taken care of. So X is this guy times 0.5 minus 90 cosine. I actually don't know what that's about. Minus 90. Okay, that's a vector 2 that centers it somehow. 90, 90. All right, so it's minus 90 puts it over there. Okay, so I'm thinking that this. Okay, so the size is 240 by 60. So, right. Okay, so 240. Why is it 90 then? So, it must be like. I don't know. Yeah, I'm gonna do this. And it doesn't really matter. Radius. Radius. Okay, we'll put the dingus and the dingus. Energy radius is 90. Okay. Indeed. I don't know how. Okay. 211. It's just ridiculously huge. Put energy size into constants. Gauges. Okay, and then literally just divide everything by 2. And probably that's GG. Oh, I don't have to paste anything. Reduce gauges. Reduce have size of energy gauge. All right, let's see how that goes. I'm just gonna blast it up to testing because I don't care. Or I don't care to set up a. No way. Proper development environment. Haha. How much lag does the stream get when Roadblocks is running? Some. Okay. Okay, so energy. Alright, so it appears to have been broken. Not a big surprise, because that was mega hard-coded. What if I undo the comment and Hi. And push that. God, what time is it? So much time wasted. Okay, so if I just like put it back, is it correct? Energy. Yes, okay. It is back to working. So we have to parameterize this somehow. Needle size. Yeah. Pause offset. Wait, what? Oh, I did the wrong one. I'm a dumbass. So wondering why it doesn't work. That says minus. Plus minus. Wait, what? Huh? Sine cos. Why is it cos sine cos? Right. Because it's different. Alright. Whoops. Whoops. Shut up. Shut up. Revert. Whoops. Alright. Good job. Yes. Wait for this. Q. D. And done. Okay, so I got it right first try, but it's well, that's certainly smaller. Maybe, maybe a bit more useful. Bruh. Really? Bruh, okay. Okay, so it doesn't take up your entire screen anymore. Okay. Neat. Parameterize. GG. Oh, I guess I can do the other things. Indeed. Unused. Okay, goddamn Roblox. Okay, thinking. I am thinking. Yes. So, Mr. Energy Gauge is needing text. Text. Mm-hmm. So it generally starts at around 0 and then decreases as you lose energy throughout the map. But energy is like a integration of some other value. You're supposed to like compare two values. The absolute value doesn't really matter. Uh, so I think that maybe a more useful measure would be to compare it to the end zone height. But now, what if there's multiple end zones at different heights? So, I guess I could do the bottom of the map. That would work. Let's start with simple. How the hell do you use this? Basically we want to copy the HUD. What's our units? Our units is like joules per kilogram, or because like it's. I mean, well, no. Okay, well, the units. The units are here. Yeah, no, it is joules per kilogram. So it's meters squared per second squared. Let me grab the little squared thingy. Squared symbol. Yeah, man. Squaredsymbol.com. What? Why? Huh? Can we like, can I like copy this text and then see ya? Did I get it? Jeez. Okay. Ew. So I'm going for energy if energy text energy text energy text dot text equals toString. I guess we can like format to f units squared per second squared. Energy. And then now we add HUD. Indeed HUD. Okay, so basically it's gonna what? Shadows. What the heller? This looks like a poopy rebase. What about here? What's going on here? Yeah, the shadows are previous variable. Sys. Just checking the player. This is Gooby. I wish I could disable this rule. Shadowing variables is fine. Uh, mm, mm. Where text, show text, top record, text, text, top fill, top box, bot box, bot text. We want exactly this. Z and x equals 6. Drag bar. Okay, we energy needle way. Visible equals false. Q box text box. Boom. Oh my. Oh my. Draw background. Bruh. Size scale. Let's see what happens. Yep. Okay, so this is called energy text. Wait. And this is units squared per second squared, you know? You hear? You know it. Okay. You know, it'd probably be a good. It'd be good to just make it so you can click the energy gauge to like switch the modes. Oh. Whatever. We'll start with this. Remove unused. It's a bad fix, bad rebase. That is GG. Sure, whatever. Okay. Gauges. Add energy text. Yes. Down. Down, boy. Down. Okay, let's see what happens. Huh? Alright, wait for this. Oh, it just is too fast. I can't go like do something. Okay. This is slow. Oh. Vinegar coffee. Okay. Energy. There is no command. Somebody made a mistake. 1109. Who did this? I can't believe you've done this. I forgot to close the frickin' if statement. What a goob. Oh, I don't have to copy anything. Okay, so A. Yes. 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 This needs a zap. I'll be right back. Really? It can't handle. It can't handle this? Oh, it's full screen. Why is it full screen? Okay. Start server. Okay. Energy. With a slash. Alright, now we can see a number. Interesting that it's on top. It's a huge number. But like you can see, it doesn't change until you miss board. I believe the 0 point is in like the middle of the start zone. Let's go up. So what I want is to be able to see the energy. Whee! 800,000, whee! Basically, what the energy means is how high you can reach if you were to convert all your speed to, if you were to launch straight up on a surf ramp. So very useful for surfing. Comparing surf runs, if you lose energy, that may not show up as well on the velocity, because like it counts vertical and horizontal velocity, whereas the velocity indicator only shows the velocity indicator only shows your horizontal speed, like this one right here. These are two numbers that exist. Yeah. Surfing. It's interesting how it jumps. It sort of the needle jumps around whenever you land on something that's at a different height. I want to be able to like hide the stuff. Yeah, I'll just leave it. All right, good enough. That is my gift. My gift to you. I don't feel like it. I'm going back to the other. All right, we're gonna go and do other things. All right, get out of here, Roblox. Who uses Roblox? All my homies use Strafe Client. I don't have any homies. That's not true. Oh yeah. It's the all my homies use Strafe Client part. That's not true. I guess both of them are not true. That was 2 lies in a row. That's a record. Strafe Project. Yes. Yes. Okay, so the problem I need to fix is floating point number conversion. That's so boring to watch. Well, it's got to get done. Library, fixed point, source code, fixed point. It's like halfway down here. There it is. Oh, it's the fixed point to floating point conversion code. How exciting. Wow, I have a picture of how it works. These are the digits of the number, and they are shifted like a floating point number versus a fixed point number. You align the digits according to the exponent, and then you insert the digits. Wow. But it's wrong sometimes, somehow, for some reason. And it shows up in the tests. So, library, no. Yeah, well, yes. Fixed cargo test release, right. The test failed. Tests 36. Okay, you need to stay open. Tests. Oh, geez. 36. So that goes into a floaty poity hoity-toity. The very first test fails. The interesting thing is that it's close. So this number can actually be exactly represented in floating point, and yet it picked the wrong number. It just didn't do it right. Why? So this is into. So this is fixed point into floating point. And this is from floating point. Fixed point into floating point. So that's the wrong one. The other one is, I guess it's above. Into floating point. Okay. Haha. Hey. Digits. Is this the problem? No. Is this the problem? Who knows? -1. Why is it -1? So okay, this is okay. Yeah, no, it has to be this. This is making a mask. Indeed. Okay, so that's just a mask, just like this one. Is that the exact same mask? Bits -1, Matissa bits. No, Yeah. Okay, so it's something to do with the mantissa, though. Equals digits I. M bytes. So this is M bytes is the mantissa bytes of the floating point number. Um. So that's either a U32 unsigned 32-bit integer or U64. So it'll be either 4 bytes. Ooh, I don't feel good. Ooh, the coffee had a bit too much vinegar. Okay. So it's either 4 bytes or 8 bytes. Doesn't really matter. How would those bytes be wrong? We're just copying digits, unsigned. Where did this come from? Unsigned. Ah, 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 ah. Let's just print the number. Hi, I'm the number. Print line. Hi, I'm the number. What is up? Self. Question mark. Wow. All right. Self equals. Wow. Wow. Okay. Indeed. No capture. I guess it's okay to capture. All right. 4 0 0 0 0 0 0 0. Looks right. Where did this little bitty guy come from? What even is that bitty guy? Eh. Who has done this? Most significant bit downshift. We're just shifting and drifting. Copy digits. Is it leaking from the exponent? No, that would be on the left. That would be more significant. It has to be something weird with the bitty bytes. Oh. All right, print those bytes. Print those bytes. Print those bytes. Print those bytes. Ma'am, 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 ma'am. 0 B. Is that allowed? Are you allowed to do that? No. Fixed binary. Huh? Wait, what? Oh, okay. I didn't put the thing proper. There you go. Oh. Oh. F64. Oh. 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 Huh. Uh, 60. That's what it wants. I wish I could print it in like chunks of 8 bits. All right, next. bits. Show me them bits, boy. Is it the sign? So this is ORing, but they supposedly should not interfere. Sign is unsigned bits 1. Bits minus 1. I guess we print each of these. Sign exp. Ill. Exp. Ill. Mant. Ill. Okay, go for it, buddy. Show me your bits. What is up with the bits? Oh, they should definitely be aligned. Space. Yeah. Okay. Good enough. Okay. What is that? Sign bit. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh! Wait, what? Wait. I'm confusion. 53. Mr. Float, I do not believe you are being honest. Exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bits to the exponent of the floating point number. So the exponent is leaking bits, which is making the answer nearly correct, and the mantissa is just way off and is making it slightly different. So the mantissa bits is our attempt at like creating the number, and it's just mega wrong. Like this should be way over here, right? This bit should be right here, and the exponent goes to right here, and it should only ever have bits in these numbers here, but it's like it just like leaks a random bit. It's like it just like, okay, what? Huh? Mantissa bits minus 1. Mantissa bits minus 1. So we have 64 bits. 52 plus 11 plus 1 is 64. Huh? 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 This is supposed to be a bit that comes from underneath 0. Huh? Wah? Eh? Like if I take this, zoink, and I count the length. 54. 50. Oh. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh. Oh, I'm just printing too many. Oh, okay. Okay. So I just did this wrong. I misremembered, I guess. Oops. Okay, so that is actually not a problem. I just printed it wrong. Okay, now I guess I... Let's see. Yeah, okay, whatever. How do you just say do it? Unlucky. Can I like echo? Oh. Okay. $64. Okay, so there is now 64 zeros in that number, and I was misinterpreting it because... Okay, where is the poopy... Where's the little issue coming from? Because, like... What's all that about? I have a feeling it's something to do with the mantissa. Where, like, the leading one is implied. I forget how. Implied. Wow. I have implied. Yes, including one implied bit. Okay. Okay. Okay, I think I understand the problem. So the mantissa is just straight up wrong. It is wrong. And so it's calculating this at some wacky offset, but it should be at 53 and it should be at cutoff because it's implicitly 1 within floating point. So the calculation is wrong. It is wrong. Okay. 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 But okay. I I fully understand floating point with no mistakes. No caveats. Uh so what do I do then? Okay, so it's not like there's a rogue bit coming out of nowhere. Um it's that the the I value here is wrong. Most significant bit is hello, I am here. So what how far off is it? So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bits to the left? Cuz it should live in this bit, but then it's masked away. And it's the implied bit of the mantissa, the floating point mantissa, and all the rest of the bits are zero. 13 bits minus 13 11. Where does that number come from? F is 32. Should be okay. Wait, what is this? Wait, why are we doing this? For that? Isn't that dumb? Yeah, man. So this is a U32, I believe. Oh, okay. No, it's okay. But like double casting. Ba 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 ba. Wait, what? 1F. F is U size. Unsigned. Why did it like that? Unsigned plus minus U size. Unsigned is a U32. You can't do U32 minus U size. Huh? MSB. F. Oh, F as unsigned. I understand. Okay. So it's not this whole thing as unsigned, it's F as unsigned. IZ. So like this is already U32. Right. But it also needs to be U more somehow. I don't know if this is going to help at all. How do we end up so far off? Is this, did I just like flip it and it's like just mega wrong? Okay, so if this is unsigned, oh no, this is U32. Digit shift U32. It should be okay. Downshift digit index m bytes len id msb. Okay, so this is the issue right here. Digit shift. So this is this right here is where it needs to be as usize. So we don't need 64 bits until right here. Manticipate. Manticipation. So was it right before? I don't know. All right, so this is not the problem. This is not the problem. Let's see it. IMID. Okay. No. Yes. Okay. 2 0. IM is 2. So IM. IM is the index of the mantissibytes. So it's starting out on number 2. So that means we're in this path. So it is actually exactly this case. So the index in this list, so this is 0, 1, 2. We start right here with IM on this index, and we go boop, boop. And so we write these 2 bits into those 2 bits. Bytes. They're bytes. Except this has length 8 bytes. So there's 4 more that we're also writing. Is that correct? So the dingus number is like that. So that is, we have 32 fractional bytes, bits right here. Oh, excuse me. So let's look at these 4 bits right here, because this is hex. 1, 2, 4. So it is there. It's the bits, the fractional bits of the fixed point number read 0, 1, 0, 0. So it's 30 zeros, 0, 1 followed by 30 zeros. 30. So that byte looks like, I guess it's like 40 hex. Okay. Nice to have eight fingers handy for bits in a byte. Okay. So if we start on digit 0 of the digit 2 of the mantissibytes, we're covering 6 digits, and we start at digit 0 of the fixed point digits. That doesn't sound right. I think it got it backwards. By it, I mean me. I don't know how this got there. Okay, let's print hex. Help. How many hexabytes are there? 64 divided by 4, 16. Okay, X. Surely that helps, right? Yeah, so helpful. Okay. 8. H. Okay, 1, 2, 3, 4, 5 bytes. Right. I think I'm just like messed this right up, and I need to rethink it from the start, from scratch. I think this is probably straight wrong here. Type situation. Help. This is IMID. Like, okay, if there are more significant bits than mantissa bits, then we need to have we need to start with ID. There are more significant bits than mantissa bits. But indeed, that is actually not true. There are 53 mantissa bits, and the most significant bit is 31. Print it. Print it. Help. Eh. 31. It's 31. So, if most significant bit is greater than mantissa bits, then we're doing like this. Most significant bit is greater than mantissa bits. It reaches beyond the mantissa needs to cut off the fixed point bits at somewhere because it won't fit into the mantissa. Otherwise, is this even correct? Does this even make any sense? So like it's kind of it's like this 0. So that's the most significant bit. Most significant bit. The least significant bit of the mantissa is lower than the least significant bit of fixed point. The least significant bit. This is the least significant bit. This is the most significant bit. Or well, like this is the most significant bit, but this is the most significant set bit. That's what bit width is, which is poorly named, but we're like inheriting legacy C cruft, so great. So 53 minus 31 is a number that is what, 22 or something? Let me actually do that. 52 minus 30 is 22. I got it right. Okay. 22. Hi, I am 22. Digit shift 22. Oh god, I don't know 22 in binary. Throw away the bottom 3 bits and divide by 8. Shift right by 3. 3. It doesn't know that. Okay. Unlucky. We can just do this. 3. 3. $22 divided by 8. Almost 3. So 2. 2? 2. That's what we see. 2. So I am starts at 2. Does that make sense? I am starts at 2. We have 8 bytes. Let's actually draw the real picture here. So we have 8 bytes. And this has mega million bytes. I don't know why I said that. It has some other bytes. It has exactly this many bytes. Okay. And our number is exactly 40 hex 0. And it's okay. So what number is that? 128. No, 64. This is 64. It's, it says we're starting right here at index 2 with this over there because we actually are missing 12 bits. And this is 8. This is wrong. Okay, so it's all wrong. It's all wrong. It's off by 12, 13. It's 13. I forget. Let's look at the numbers. I ruined it. Help. 16x. 64b. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This one needs to move 13 shift left. Is wrong. So is that wrong? Where is that wrong? Downshift. Let's print that. Oh, yeah. Downshift 7. 7. Whew. Jeez. 7. What is 7 to 13? 7 plus 6 is 13. Digit index is 3. What does that mean? Hi, I am digit index. Digit. 3. 3. 3. 3. 3. 3. 1. 0, 1, 2, 3. So in our picture here, 0, 1, 2, 3, this digit index is correct. 3. That's the digit. There it is. Digit number 3. Why don't we write this in binary? Because it's too much to handle. 0, 1, 0, 0, 0, 0, 0, 0. Indeed. And then we can just right there as well. What? 16. 16. It's off. It's way off. This bit is supposed to be whoosh over here in the Bubba bytes. 8, 9, 10, 11, 12. 8 plus 4 is 12. It should be right here. Is that true? No, it needs to be right here. Because, so the bits start here. So that's the rest of the, so there's like, imagine there's this many zeros and all those zeros. This is how it needs to line up. So, and I feel like this calculation is wrong. So this is like quite right. Digit index. So we found the correct digit to read from. And then throw it away. Most significant bit minus mantissa bits. Yeah, that just sounds right. But we're not in this case. Mantissa bits minus most significant bit. So that's 53 minus 31. Starting. Okay, what is the alignment here? This is 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it needs to be number 4, like this. And then plus 2. How do I get that number? So the idea is to write this into there and then shift it down by digit shift minus 1. Why is it minus 1? Minus 1. Downshift. Downshift is 7. But it should be 2. Downshift is 7, but it should be 2. How did we get here? Okay, what if I just... Okay, it's still 7. How does it remain 7? Minus 1. I just don't really understand what that's doing. It seems bad. Oh, silly, silly, silly. How do we get that number? Okay, then that's 3, not 4. Confused. How did it get so far off? What does what I have mean? So I think this makes sense here, and then I just kind of like flipped it because that's kind of how it works. Is it like shifts against the bottom? But it's very clearly wrong. Essentially, you want to put the top bit of the fixed point number at the top bit of the floating point number. So the top bit of the fixed point number is most significant bit. So the relative shift is this. So you're trying to start, my fingers are these digits. You're starting at the bottom where my cursor is of the fixed point number and writing each bit into the mantissa, which is m bytes. And that's what this while loop does, it's writing the bytes in one at a time, starting at the lowest one according to the alignment. So it says this bit is 31. We want to get it there. We want to get it to 53. It's byte number number 31, and we want to shift it up to 53. 53. Shift it up. This is shifting down by 7. Down by 7. Man, I use AI so little, and I have the like itch to go, oh, just make AI go do it. Degrading my performance. AI. My problem solving will not be outsourced to AI. Do feel kind of stupid here. I am actually just not seeing the problem at the moment. Okay, so I guess this copies the bits the bytes in a way that doesn't overflow either list. It doesn't go out of bounds on either list. The numbers are very carefully set up here so that the minimum digit of the lists line up. That has nothing to do with the position that the bit is supposed to end up at. This is the final shift. Not downshift. So this is the shift that needs to be applied at the end, and this has nothing to do with anything. Oh my god, bro. So this is just nonsense right here. How do I make this right? I don't see any other way. Oh, wait. Meant. Yeah. So is that always true? Where if then down, who is this? I am most significant bit, and Manticipits is less than me. So I need to be shifted down. That makes perfect sense. We can call this shift equals to this. Boom. And then why don't we do normal terminology here? So this is right shift. I don't know. I like up down better, but who am I? So then lefty shifty. Zabazoo. God damn it. It's like that. And it's just, there's actually just no relation to those other values. It was simply wrong. And now it is simply still wrong. Oof. Oh, it was right for that one number. Yay! 31, yay! Okay, it's also right for that number. But our bigger number is okay. Okay, what are we looking at now? Most significant bit equals 64. 64 bits? $64. Negative 7 trillion. D is 1. M is 2. U. Wahapam. D4. Okay, so I got the sign bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the exponent bits. Hi, what is this? I am making a function that converts from an arbitrary width fixed point number to a floating point number. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. How did you end up there? 8. Huh. Huh. 8. 8 is 1 byte. Probably -1, right? Mantis bits. But would that break everything? Zero. I don't know. ID right shift. Most significant bit. D. Most significant bit. It doesn't make sense. 64. What do you mean 64? Bit width is 64? What the heller? So it is -1, right? Okay, let's do some testing. Rust Playground. Hi. We want it 0 U64 bit width. What number happens? 0, I think. All right, I can just write 0 now. Yeah. 0. Okay. Okay. And then if we say, I I64 min as U64. I believe that's a 1 shifted all the way to left. 64. 0, 64? One, two, three. Yeah, 64. I see. So it's not the correct like logarithm of the number, and that's what the -1 is for. So this is -1. What if it's 0? Ah, I see. Okay, so it handles it. It's completely separate. Yes. Yeah, 0 is 0. 1 is also 0. So what if this is 0? Hi, I'm 0. -1 minus f. Bias. Right. Bias is crazy. Most significant, but I wonder what happens. Is that true? Is that true? Do I have a test for 0? Wait. Oh, 512. I believe I have no test. It's probably wrong. It's probably wrong. Expected, observed. Okay. Okay. Let's see if it's wrong. Are you wrong at 0? No. Interesting. 0, 0, 0, 0, 0. M6. So it just invents something based on nothing. What would this be? Let's see, I guess. So if we do saturating sub 1, this must be the index. I'll say this is the index of the bit. So dot bit width equals 0. We'll just say like dot MSB equals 0. And then freaky deaky 1 0 equals 7. Of the most significant help can't 0 is equal to 0. So this is where the saturating sub comes in. So like, what is the index of the most significant bit? There is no most significant bit, so just start from the bottom. You're good. And that works. What if I do not do like this? No. Then we end up with this. But is it right? Can I eliminate this case? Who knows? I'll have to take away the minus 1 there. Okay. Haha. So now we've failed on 0 because it's wrong. Haha. Ha ha ha. Haha. Unsigned is 0. We can actually if it's 0, we can just special case it. Like why don't we'll put this down here, and then we'll say if this help, then just do something else. Okay. Return fixed 0. If the number is 0, return 0. Duh. Okay. So now we can skip it. Sign. Yeah, we don't need the sign if we're just hard returning. Okay. Okay. Good. Oi. Expected F32. Ooh. Am I allowed to say okay, so I just, by the power of Rust, just parsing it and doing type inference, it's like, oh, I see, this is a 64-bit. Oh, I see, this is a 32-bit. Because these are two separate Finkles here. I could say as output, but like, whatever, man. Whatever, man. That's unfortunate. I don't like if statements. I would rather this be one lovely block, but we're using positive numbers here. We got to stay positive. So -1 is not real because we're saturating sub here. This is the index of the most significant bit. Wow, wow, wow. And that's how it works. And all bugs fixed. Except for the ones that weren't fixed. 63. So now this says 63. Shifting down. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 1, 2, 3, 4, 5, 6, 7. 63 versus 53. What number is this? Isn't it supposed to be a mega number that's mega easy? How do we end up with a stupid idiot number that's an idiot? 7? Oh. Oh, it's not 0, so this never happens. Wow, 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 wow. Wow. Wow, 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 wow. I suppose I could also do a checked sub here. Diverging. Cause like, I don't know, this is like a full copy. Unsigned bytes. Bit width. Oh, oh. So we could say let equals checked sub. Else sum. So now what was 2 calculations is now 1 calculation and is potentially, I don't know, it's something. Ooh, ah. Realistically, what the hell is that? This is the index of the most significant bit. Uh-huh. Okay. Realistically, I don't know. I put sign at the top because it's like the most significant bit. And like I was kind of doing things in order, you know? You hear? Sign. EXP. Mant. Okay, so this is just still wrong, just in a different way, or with like slightly better maybe code. Most significant bit equals 30. Okay, so we're still off here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. So it's max or min int, I guess. Test. Add 0 test. Plus. That's neat that these have nothing to do with anything. Why is this off by 7? D1. Okay, so left-hand side seems to be working great. But then if the right-hand side procs, we are now not correct. That is not correct. D, huh? Seven. Wait, what? Oh, we're up here. Right shift. $63 minus 53. So we're right shifting 10, which is it starts at 1. 10? Wait. Oh, am I dummy stupid? Am I dummy stupid? Yes, I am dummy stupid. this is where it applies. We need the thing. Right. 53. So. We're in there. It should only be 7 bits off. This one can be many bits off. But this, well, yeah, no, 7. That's correct. But so this one can only be 7 bits off. This one can be many bits off. I did not understand that. Left shift. Oh, okay. I guess we literally just mask 7 bits, which is also known as the thingy, this guy. Help, where am I? Who did this? We're up here. Okay. This is a U size though. Is that gonna kill me? Nope, we're already U size. Digit width -1. Digit width 8. Is that happenstance? Yes. I guess we'll do this. 1 shift left, digit shift -1. Because then it's not happenstance. So we're masking the right shift because it's like already right shifted. Do we even need to do a right shift, or do we actually need to do a left shift? I don't know. So it's in the middle of the thingy. It's in the thingy. So it needs to sometimes shift left, sometimes shift right, if I am not mistaken. Because we got bits. This is the number. The number is the number. M bytes. What is going on? Let me think for a second and then speak instead of making up nonsense. Okay, why don't I insert this diagram? That's pretty decent. So this is our mantissa that we're trying to do. What's our case here? 1. So we're off 1 digit here. We're just cutting off 1 digit. We're filling this in, and then this is 0. This is not 0. We actually have the biggest possible negative number. And it needs to become like this. Mimi, which is a downshift. But if our number is like this, it still needs to become like this, which is an upshift. So we need to compare mantissa bits. Does this apply to both? Yes, it does. But I can use a trick. I can offset. So instead of having an if statement here that's like, oh, should I upshift or should I downshift? We can just smash it into this bit over here and always downshift by between 4 and 12. No. 4 and 11, which is 4 plus 7. That way it's always a downshift. Ish. No, this one is different. Ugh. There's one case. So I can actually, the case up to here, it's the 0, 0 case where there's equal to each other-ish. I'm trying to minimize the number of if statements, and it's just getting hard to follow. Oh, it's so much more complicated than I thought. We're in the atrium. Four. I could offset by 4 bits instead of a whole byte. And then the shift would be 0 to 7. And it would always be a downshift instead of like possibly shift up by 4, possibly shift down by up to 4. Or 3. I don't know which one of them would be 3. But this sucks. I need to bias it and spill the bits into the higher thing, and also maintain always using positive numbers. D. How far into D? So like we could just do a straight up plus 1. Like say, hi, 1. Zero to 7. No, that'd be 4 to 12. Mandatory. One. Yeah, 1. This sucks. I need to think about this all day, but I'm out of time. Well, no, I'm not out of time. I have another hour actually. I'm chilling. We're good. Okay. Focus. I had an entire cup of coffee. I can't believe these are 2 different cases. One is always left shift, one is always right shift, but you had to be very careful. I'm going to need to bias it by 4 bits. Um, no. It's Mantissa bits masked. $53. Oh, it is. $53. Uh, nice double typo. Ching, 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 ching. Zoop, zoop. Yeah, it always has to go like that. It would be easier to just make it 8. 8? 24, 32, 24. We're good. 53. Yeah. Yeah, this is simpler. So M is always 1. So when does this happen? So most significant bit. Crap. Plus bias. It's hard coding. Ah! Plus bias, right? So it's plus bias. So we select farther. Does that make sense? Right shift, hello, +1. Who are you? +1. Do I want that? ID. Yes. Because then we shift the whole thing down. It's already included easy clap. Surely. Okay, not bad. That might actually straight up just do it. But also kind of not. Help. Whatever. Oh no, it's all wrong. Whoa. Oh. Got pretty far actually. I didn't expect that. Yeah. Good. Okay, I should like really write this down because it's actually quite complicated. I mean, actually, it's the same idea. Uh, both F32 and F64 have 8 bits of room in the Mantissa repr. I'll call it unsigned. Indeed. As U32. Oof. Plus bias. Does this apply here? Let's see. So we made it to 329. Okay, still there. Now I just have to like think really hard. E22, and we got 0.55. Look at all those bits. 2 F64. Where is that test? Oh, is that this one? 35. That's a lot of digits. Holy smokes. It's pretty cool. How come it's like close? I think what I need to do is just like slide a number like 3, where it's like 2 ones, and just go 3 times 2 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 times 2, and just make sure it works everywhere, and that should be good enough to just like use 3. Actually, how about 16 ones in a row? What number is that? 2 to the power of 16. 65536? 65535. 65535. 65535 times powers of 2, both positive and negative. That sounds like a good idea. Make sure no bits get lost. Should be able to just replace all of this. The cool thing here is that all float 32s fit into a fixed 512 bit. All representable float 32s fit in a 512 bit number fixed point. It's pretty neat. I just said the same thing twice. I was going to try to say it in 2 different ways, but I failed. Yeah, because the exponent bias is 127. So the exponent can go from positive 127 to negative 127. And you have 256 fractional bits. Actually, does that mean that it's half as big you can do? F256? Is that true? Yeah, right? F256. To do. Use the number 0 B 1111 1111 1111 1111. We can do like this. And test many powers of 2. Test. Bias. I forgot to add one, didn't I? Not quite. Not quite. Not quite. Mm-hmm. 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 This is wrong right here. Ah, I love this song. Hmm. Mm. This is how much too large it is. But then we're jumping up by D. Whereas this one is not jumping up by D. So it doesn't need to be shifted. Variable amount. So it's right shift minus that plus bias. Right shift minus that plus bias. Kinda of. For, well, What is the itinerary today? Work on stuff until I'm out of time. This is like I have to be very focused here. Um, it's a integer to floating point conversion process. I'm finishing up some other work. Really hoping I can finish this today so I can be released. Does that make any sense? So it's going to be this is 0 to 7, but it needs to be 4 to 12 or 3 to 11, something like that. 4 to 12, yeah. 3 to 10, I don't know. Because we're now inhabiting this bit, or this byte, and it always has to shift down at least 4. So that the most significant bit ends up right here. And we never have to do a left shift to move the most significant bit up. Most significant bit plus bias. So we're moving dying. Like minus this number, right? But I don't see. Maybe that works out. So but that just does 7. Up to 7. But we need more. 7. We need more. I don't know. Is it okay to do 8 to 15? I have no I have no idea. I have no idea. Just gotta keep thinking about it. Eventually, the thoughts come through. All right, well, this is like exactly the same as what was there before. So what happens when I do this? Yeah, so it still fails at this exact same point because it's wrong. Is it Mantissa bits masked? But that's not true. We want right shift. Mantissa bits masked. Okay, masked. Plus minus. Something. It's like mask it plus minus. Or something outrageous like that. And the bias. All right, let's try it. Let's try it. Right shift plus Mantissa bits masked. And then masked. And then not masked. No. I'm lost. So we're biasing the significant bit so that it ends up here. And then I can downshift 8 more bits to put the one in the 53's place. This is the 53's place. Zero to 7, 8 to 15, 16 to 23, 24 to 32, no, 31, 32 to 47. Am I dumb? What did I do? I did something wrong. 32 to 47. 32 to 4. 32 to 39. And then 40 to 47. And then 48 to 50. No, 48 to 55. And then 56 to 63. Not confusing at all. So I'm abusing the fact that the number has room so that I can always do a positive right shift. Instead of needing to sometimes shift up by 4 bytes, sometimes shift down by 4 bytes. 0 to 4 bytes. Sometimes shift up by 0 to 4 bytes, sometimes shift down by 0 to 4 bytes. And one of those will not be an inclusive range. I don't know. When, why, how, what, huh? Okay, let's put this back. So this is our digit index. The digit is the fixed point number, and it's made of bytes. Each byte has 8 bits. That's a number, and it can be 4 bytes wide, it can be 8 bytes wide, it can be 16, it can be any number of bytes wide. And it specifies where the fractional part starts by a generic constant. So 0 means it's at the very right side. It's at the least significant bit. And in this number, which is a 64-bit number, 64 would mean all the bits are fractional bits, right? Yes. Yes. But generally it's 32. I only ever use it at half currently because Rust does not have const generics, so I can't make more advanced functionality until const generics are stabilized, which will be a very long time. Probably not for at least 3 years. But I can still use it right now with macro madness, which we can see right here. Yay, macro madness. And just set the fractional part to always be half of the bits. Okay. Wow. It's a fixed point value with 64 bits. And we're taking the bits, finding the most significant bit, and then biasing it, shoving it in, and then unbiasing it. Bye. One bias. One. Zero, 1, 0. I don't understand. This. So if this starts at 1, that starts here. There's two ways to do this. I can have like a fractional bias and have this IM value be sometimes 0, sometimes 1. And if it's 0, then the number is at the 4's place within its digit. The alignment of the most significant bit is at the 4's place within its digit, meaning I can do a shift down. I think that's dumb. I think this should be a constant, and it should always shift down by at least 8. Does that make sense? By at least 8. No. It doesn't make sense. Because if the number is this, it needs to shift down by 4. And that 4 is less than 8. So it's not at least 8. It's 4 to 11? 4. Wait, what? Shift down by 11. Are you mad? No. Because if it's here, that's 1, 2, 3, 4, 5, 6, 7. Plus 4 is 11. So it's 4 to 11. How did we end up here? So it's always starting there. Right shift. This makes sense here. But then how much do you shift down by? Okay, if our most significant bit is 56 plus 1 no. I am is plus 1. ID is not plus 1. Four. It's anticipates minus 1, right? 52 modulo bias, modulo 8. So we're trying to move the most significant bit into the manticipate slot. The Z place. 53's place in terms of binary. The 53's place. It's 0. It's 52's place. It's 52's place because this is the 0's place. Is it right? Whatever. It's fine. It's fine. The decimal is somewhere. Whatever. Whatever. Okay. We're trying to move most significant bit downshift to here. This number is compensating. So we need to subtract it off. So let's see. Let's say this is right there. This is 0. So this is 63, 56. This is the 56's place. 56 minus 53 is down by 3. But we need to move it to move down by 4. Oh, do we? That would put it right here. 52's, right, 52's. Minus anticipants minus 1. I'm subtracting by 1 here. And confusing myself. How is this correct? So it has to be downshifted by 4. Most significant bit is 56. Manticip bits is 53. We need to say minus 1. So 52. (51 minus 52). So it's artificially how does it bias. So it's yes, yeah. What is, okay, yeah. Am I doing is it going to be like most significant bit mod 8 minus manticipants mod 8 Because then that's 0 until oh no mod. Well, no. I I'm kind of ashamed that I can't figure this out. My past self would have just done it, seen through, but I don't see it. I cannot see. I don't understand how to get the 4 to 11 behavior where it's modulo from 4 to 11. Like obviously you can plus by a bias and then do the modulo and then subtract, or you know, that gives you a negative number and then subtract. I guess no. Backbones. How do you do it? Just do it, man. When do you do the modulo? Why don't I write it in like Lua notation here? So it's like MSB mod 8. That's a number. Plus mantissa bits mod 8. That's a number. Does that do it? So this does need to be -1. So let's say this is 52. So there you go, +4. Was that really that hard? Are you kidding me? Like, something's wrong. What is 52? 52. 52. Well, I don't know. It's okay. Well, just run it. Which one's the right one? Right is right. Smaller. So the biggest, the leading. It should be one down. One down. Like this. I don't understand how this comes into play. I just feel like a different person. So if I plus 2. Plus 1. Am I looking at different numbers? 329? No. Let's say whatever. Is that even the thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not even different. 1, 1, 0, 1. It's not even different. 34. 34. What? Shift down. Did I not write plus 1 there? Why would it not be different? It says it's different, but then this is the same. Oh, 3. Okay. Plus 1. Plus 2. Plus. So I subtracted 1. I am mega, giga confused. Whatever. I can't have a literal. Whatever, 64. Go for it. Yeah. What? Oh, it's before. Goodness. Okay. So, our bits are 2, 3, 4, 5, 6, 7, 8. Like that. Our bits are pretty jammed in. What does it say? I think it's 329. What's a number? 320 is a number. 29? 329. Right. So mod 8, that's 1? Why would it be 0 up here then? So I believe this needs to be shifted down by 7 plus 4. 6 plus 4. 10. Down 1, 2, and 8. 7. Wow. Okay. 1, 2, plus 8. 10. Jesus Christ. Think one thing, say another. I said 2 plus 4 is 7 when I meant 2 plus 8 is 10. Okay. I'm losing it. I feel like I can't do the simplest things. I'm loaded with caffeine. I'm trying to bit shift down by a variable amount, but I can't figure out what the amount needs to be. I'm not used to thinking. I'm used to being handed the answers by my something inside my head, and it just isn't happening anymore. The genius went away, has left the room. It's the glasses. No, I think it's much older problem than the glasses by a year or so. In fact, the glasses help with not having mild headaches all the time. Okay, why don't I print this number that's happening right here? That would be a smart thing to do here. Well, okay, that's... It needs to be 10. And it is 1. What? Manticipits minus 1 masked by 8 is 4. Is this like order of operationing? Order of operationsing me? No way. Where else is that happening? Sheesh. I get order of operations. That sucks. Why is it 5? Most significant bit is printed as 329. Yeah, so we get 1 off of that. And we're just throwing away all the bits because this number is straight up wrong for no reason. Is it though? Yeah. Yeah, 10. It's supposed to be 10. Where do you get 6 from? Shut up. 1, 2. That's not going to be confusing at all. Go. So it's 277 above the mantissa bits. 277 above the mantissa bits. Which is, what, 11 above 256, which is 3 above 264. God, I'm stupid as hell. 77. God, what was I thinking? It's 21. Oh. How do I not have dementia or something? Like, I'm a functioning human being that can no longer think the way that I used to. How do I still function? It's like someone went in my head and ripped apart all the smart bits. I've been constantly using these neural pathways for 10 years. For 16 years. They should be my strongest pathways. I said 277 minus 256 is 11. It's not. Okay, 21 mod 8 16 4 5. So yeah, that makes sense. It's 5. But that doesn't matter. It doesn't matter. Wait. Is that happenstance? That is 5. Minus. Plus. Yes. It is, I think. I think it's like because this is both +4 and -4 in like modular arithmetic. I don't know why I say modular because it is literally modular arithmetic. Actually, I'm gonna go to the bathroom. Can I do this? Does this work? Yeah. Okay. Guess what? Cheese buff. The camera just did not look as good as the other camera. I need a capture card that works with Linux properly. Oh, which is painfully good. Hollandia mild Gouda. I guess this camera's backwards. Oh yeah, that's the stuff. This is mega pack from Costco. This is totally wrong. Right back. It's however much bigger it is. How do you modulo subtract good? I've made my constraints super complex just to use like positive numbers. All right, this is mega wrong. This is mega wrong. Same thing. I have to minus plus. All right, let's write it out. Minus that and then plus that. Right? Is that minus minus plus? Maybe. Yeah. Okay, that was the confusing part, I guess. Oh. Two's complement. You can just like do two's complement and then mask it. Right. Or not. Yeah, I can't just rely on my intuition anymore. I need to actually properly think through the problem with my prefrontal cortex, with active thought, instead of just waiting for intuition to answer. I'm going to have to put in work to become as smart as I used to be. Burn new pathways. New neural pathways. This just looks so weird, but that's kind of what it is, because it's you'd like modular right here, mod 8, and if you have cool numbers, then you're good to go. But we don't have cool numbers. Oh, I'm stupid. Oh, obviously. So, okay, well, but then it's still hard. Right. So you do this plus 8 minus this. So this is like negative numbers. 8 minus this mod 8. So that's just like that. And then this mod 8. And that gives you the 4. So you want this number. You want that number. It's the right number, but it just needs to be in the range 4 to 11. And that gets done by this code. Okay, so is 8 bias? No. 8 is something else. Digit shift thingy. I'm just gonna smash it in. I am done at this point. Actually needing to think is crazy. Only idiots actually need to think. Interesting. What's going on here? We have a rogue 1 right here. I think I may have forgotten to... Oh, did I actually just write modulo? Wow, what an idiot. Okay. Modulo and masking are the same thing. Yeah. Minus where? Oh, it's trolling me. Okay, I see. I'm getting order of operations again. This one is right here. Need more brackets. Get order of operations, idiot. 10 to the minus 1. Are we good? Maybe that's enough brackets. Haha. I know what I'm doing. Definitely, yeah. Nope. So did we get the bit there? No, it's off by 1. I think I recognize these bits. 1, 0. No, I don't. So these ended up right here. And then it went and went and went. And it's off by like 8. This bit right here is supposed to go like here or somewhere like that. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So this bit is supposed to go on here and it gets cut off. And we see 0, 0 right here. Should see. But we don't because my calculation is still wrong. Woo! And now I no longer understand it. So I subtracted 1 here to get the index. And now I'm like unsure. Like everywhere here it's -1. So I should really just rename it and use it as -1. Oh. 23, 52, Mantissa, I mean, it's kind of still is Mantissa bits ish. Well, yeah, it literally is Mantissa bits now. But I am meaning it as like Mantissa MSB. You idiot. Yeah. So now it's makes sense because we're comparing most significant bits. So I did a thing. Let's see what the right shift says now. It still says 5. 10. So this should be 10. Okay, but this, let's make this a constant. Plus. Or U size? I don't know. What do you? U size. Okay, so we add the negative Mantissa U size alignment. And then add positive here. And that puts it in the range 4, because this is 4 to 11. But I have probably made a grave error. Like, you like this or something like that. I don't know. I'm just gonna do it. Why not? 9. How are we passing all these when I'm just like magically changing the code? Happenstance, I guess. Like, was this 6 last time? No. I'm guessing here. What time is it? I've probably spent an hour on this at this point. Oh, I'm over time. But no signal. I can't believe I've spent an hour and a half in this one spot and I haven't really made any progress. Makes me feel incompetent. The absolute placement nine. All right, are we like, do we have this here at least? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're at this 0. It needs to be one more over 10. Like I knew. That's why I was saying 9. Like, what is 9? Why is it 9? It needs to be 10. Most significant bit is printed as 329. Two. Oh, 5. Um, is this the same? Is this also 5? Nice. Okay. Yeah. So that's modulo 8. Oh, I'm just making things up. That's completely the wrong thing that I didn't want to do. Okay, 329. Right. Okay, so 329 is one more than 328. So this is a twos place. So that means that our situation is 1 0 like this. So we have a 1 right here, and this number goes on for a million billion 329 more zeros with commas like such. Off the screen, why not? So it's here, and we want it to end up like this. Right there. So this one represents the most significant bit of the number. So we went from this last digit, and we're shifting right to put it here in this bit, and that is 1, 2, 3, 4, 5. Down. And right now we are trying 9 down, which is wrong. So, rah, 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 rah. Five. So you can see I was trying to do this plus negative mod plus positive 4. So that's like a modulo range shift. You're just like changing where it like does the modulo range. But the weird thing is that it already has the mantissa most of the different bits subtracted. So you're minusing and then minusing again. And I'm just like using modular arithmetic to hide what's actually going on and overcomplicate things for fun. So this is now correct, as far as I can tell. So what do we see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We see 1, 0, 1. 11011. So it's just way off, which is mystical. How could that happen? 34, cool number 1. 34. So I took away the bias from here. Five. Oh, unsigned. Where does it print that? 64B. So this is actually a 64-bit number of the M bytes, and it ends in 8 bytes of emptiness. 1, 2, 3, 4, 5, 6, 7, 8. So we have 56 bytes. We need to compact that to 52 bytes. So we shift right by 5. That something seems wrong. By 5. It should actually be 10. So, right? Okay, let me check my stupidity again. So we have... Am I dumb? Well, yes. Dumber than I was before. Okay, I gotta not insult myself constantly. Just keep working. 329. So it's... If it was 328, it would be the zeros place. So 329 is the ones place. Because 320 is a multiple of 8. I can check that. Okay. Mm-hmm. Digit index. Digit index. It is the ones place, but I'm calling it the zeroth digit index. Bit index. So we got a number that looks like this. I guess I could confirm that somehow. Does magic numbers have print fancy? Why don't we try fancy? And let's see. Rest print binary with spacing. I didn't search it very well, but whatever. We're printing unsigned again. Oh, 0B Yeah, right. You can't dynamically do it. That's right. Hmm. I guess I can loop it. 0, 0. Hmm. Let's try that. I think it goes like this. Sure. Yay, underscores. That's right. Okay, we have a massive, 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 massive number. And it appears it's not what I expected. It says 329. But that's wrong. This says 240. Is there a 1 that I'm missing here? Is it just feeding me incorrect information? Why don't I go like this and find all ones? Control F1. Nope. That's the top one, and that's digit number 239, and it's saying digit 329. Well, I do believe that is wrong. Why don't we see if we can reproduce this? So how did I construct this number? Who is that? The guy? Yep, it's the guy. I do not want to get into that room. How's it doing? Is it like 40? No, I'm shocked. I'm shocked. 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 Okay, I'm going to need to produce a minimal reproduction. This could be a bug. Let's see. Okay, so the number is this. Let I forget how to use it. Oh. It is I 512. And we got nothing. Dot. 256. 16 for lols. And then we do print n dot bit width. Okay, run it. Unsigned. Okay, so unsigned is the same. 330. $18, $16, $256. Let's try something. Well, let's try ilog 2. Should be very, very close. Okay, so if I take away all the spaces, then there is 512 characters. Am I forgetting minus F? Well, it's fine. No, F is in the exponent. It doesn't matter for this. I'm curious how into 2 digits. I don't know. Oh, it's dummy mode. Okay. Yeah. Private method. What's it called? 2 bytes. Okay. Oh. Digits, whatever. It doesn't matter. Doesn't matter. So this is looking very correct here, potentially. Okay, so there is 512. Oh. It's not correct. All right, let's go check the documentation. I wish there was a crates link here. Search. All right, let's see if it still happens for other numbers. So is it to bytes? I mean, this says shift left 256, but this is on the right side. I should keep narrowing it down here. $58 plus that. Am I misunderstanding the bytes? Why is it not giving me an IDE? Can I please have an IDE? Are these like... Reversed. Am I printing... this is the least significant bit. The 0th. Okay, that's the issue. Iter_rev. Okay, I'm just stupid. Classic. Okay. So now if we take these and put them here, remove all the underscores. Yeah, there we go. So now it actually makes sense. So now it's 329. I calculated that should be the second digit, the like 2's place, and there it is. Okay, and then this says 329, 330, close enough. It's the 329th digit index, where this is the 0th digit index. Okay, I'm just wrong. Okay, iter_rev. That was my issue. Because like everything inside seemed to be working out. So it is not a library bug, and I don't need to reproduce or report any issue. Renum. GG. Okay. Try again. Or, well, I'm supposed to do other things now. I have identified stupidness to a sufficient extent here. Let me commit my mistakes. Okay. It's time to go. I spent 4 hours and made very little progress. Very little progress. Just gonna need to burn new neural pathways with neuroplasticity. Reinvent myself. I shouldn't have to do that because I spent the last 30 years inventing myself. But I've got all day every day. So, starts now. Bye. I'm so used to waving at that camera, but it's this camera.